Hi class. So today I am going to talk about this video is for Lab 4. And Lab 4 we're actually going to use coronavirus data from LA County. So just an overview. Um, we have the lab write-up and the output which will be due December 10th. So you will have to write up your results in APA format and I will put up an example on Canvas. You'll also have to include your output from SPSS. In addition, I just want to remind all of you that we have a final, and I will try to post the final December 15th, but it will be due to finish, it will close out on December 17th. So I'm gonna post this as a YouTube video, and I'll post the link here. This is an old link from last semester, so I'll update this link and re-upload these slides. So because it's been maybe a few weeks since you all have learned about analysis of variance, I just want to give a quick overview. But again, please follow, this is going to be very quick because the focus of this is the lab. So the reason why we learned about analysis of variance is because we were interested in studying studies that have more than two groups. So previously in the semester, we learned about t-tests, which allows you to look at differences between two groups. Analysis of variance allows you to look at differences between three different groups or more. So the null hypothesis for ANOVA is that in the population, that all of the means will be equal to each other, that none of the means will differ from each other. The alternative hypothesis is that at least one mean will not be the same. So as I mentioned, as I emphasized in the lecture, you could have, say, mean 1 is different from mean 2, and mean 2 and 3 are equal. Or if you have 3, mean 3 different from 2, but 2 and 1 equal, and all of these different combinations. But we have when you reject the null hypothesis and you have a significant f-test, you have no idea which mean is significantly different from the other. You just know that one of the means is different. And so in order to solve this, you would use a post hoc test, which I will show during our lab. So again, the F ratio is so important in ANOVA, right? This is how we know if a population is significantly different or if we reject the null hypothesis, right? We use the F ratio. So again, the F ratio is the variance or differences between the sample means over the expected differences with no treatment effect. So the F ratio helps us determine if there are any treatment effects, and a larger F ratio when it's further away from 1 means that the differences you're seeing are due to treatment effects as opposed to random just differences. So for example, any group within any population or within any sample, there's going to be some variation. For example, when we take an exam, not every single student is going to get the same exact score on the exam. There's going to be some variation. And what that is because it's highly unlikely for every single student to get the same exact score, right? Some students will do worse, some will do better. There's going to be some variation. And what that is just random, unsystematic differences. So I think it shows very clearly here. So the F ratio is the random, unsystematic differences plus the systematic treatment effects. So we have three different groups, right? 3 or more groups, we can see if there's more variation, if that's due to differences because of the treatment or the differences between groups versus just random differences that occur all the time. And then the addition of these two are all over the random systematic differences. So if you can imagine, if there's no systematic effects, the F ratio will be around 1 because there will be no systematic effects will be 0, and then you have your random unsystematic differences over the total random systematic differences, which equalize. When you have the same thing over the same number, that will be 1. So when there's no effect, that means the null hypothesis is true. So I went through this structure. I even made a YouTube video. So please review that and review the ANOVA lecture for how to calculate the F ratio, the variance between treatments, variance within treatments, and sum of squares and degrees of freedom. So what I'm going to use, again, is looking at COVID-19 data in Los Angeles County, and I downloaded the data here. Let me show you what that looks like. And actually, I think I might need to update this link. So if you just search for public health, LA County, you'll find, if you search COVID-19 LA County, dashboard, you'll get here. And then, okay, I think this is the same link. So when you go to the link in the slide, if you scroll, so show the number of cases, there are a high number of cases reported today, but you can see the number of cases reported, those cases broken down by age group, gender, race, ethnicity, and if you keep going, you can see even city community level. So like you can see within whatever city you live in, and then what the rates are. Okay, and then, so this is again city community level. Okay, so then there's a lot of, right, I'm sure you guys have been following in the news, there's a lot of media on residential and congregate settings where there are outbreaks. But what I thought would be the most interesting for our class to look at is outbreaks within non-residential settings where the criteria is 3 or more laboratory confirmed COVID-19 cases. So pretty much where there's 3 or more staff that are positive, and it lists every single place or work site where that happens. Okay, so I have that. And so you guys can look through the data set. Actually, so I had originally just posted up the SPSS data, but I think I'll also include the Excel file so you can also open it and take a look. So let me just quickly show you what it looks like in Excel because that's sometimes a little easier. So what I did was I went through settings so that they were on the website. So this is publicly available data, right? I just pretty much copied the data from here, put it into Excel. So we have the setting name. What I arbitrarily set these types. So I split them up into grocery, restaurant, retail, workplace. So my hypothesis is that that in one of these 4 places, so in grocery stores versus restaurant versus retail and workplace, that potentially one of these places will have a higher number of cases in staff. So meaning that maybe one of these places will be more likely to have staff who are positive. So if you go to that place or to that type of area, setting type, then you are potentially exposing yourself, having a higher risk of exposing yourself to someone who's positive with coronavirus, right? So that's what I was interested in. So SPSS likes reading numbers as to as opposed to like words. So I assigned a number to each of these different types. So grocery is 1, restaurant is 2, so you can see our retail is 3, and workplace is 4. And in this data set, because this was publicly available data, I kept the address in it. And then it has the total number of confirmed staff. So you guys, if you're interested, so this particular Altadena Dairy, I think that might just actually be a workplace, but let's just keep it as grocery. This site has 20 confirmed staff. Okay, so now let's open SPSS. So this is the same PDF that I uploaded to all of you in the previous labs. So let's just go here. So I just copy and paste the link from the PDF. And then for me, I think I'm always signed in. I'm using Chrome, so it doesn't ask me to sign in, but if it signs in, put in your LA Valley College sign in, and then you press on the app to start the app. Okay, and while this is loading, I will upload the data. So in this module 17 lab 4, the data for lab 4, so it'll be lab4.sav, will be uploaded here. And so what you have to do is you have to click on it and then press download. And you download it to your computer, and then you're able to re-upload it. So when you download, I'm gonna just download it. And mine saves in my downloads, but if you see this bar here, you can save it in you can show it in wherever it is. Sorry, I have a Mac, but if you have a PC, you can sometimes save in a different spot. So you'll just be able to download it. Okay, so this is almost done loading. And again, if you go to the lab 4, you'll see everything. The assignment is here. The APA example is here, and these PowerPoint slides will be here as well. Okay, so I think it's done. So what I do is I usually, okay, so I believe so what I did was I pressed on the file thing and then temporary folders, temporary files, upload files, and I go to where I saved the lab. So after you download from Canvas, go to where you saved it and then open up that lab, okay? And so then mine uploaded fine. Okay, so then in this, so then you have to click in SPSS, then press open, and then I press down this drop down, and I go down to temporary files where I just uploaded it, and I just I open it. So now it's open. So this is exactly what I was showing you guys. So again, Altadena Dairy Grocery. Here's the address, And let me make this, so I like working in full screen because it makes it easier to work with. So, oops, sorry, I accidentally scrolled. And then I have the number, right? And then the total staff. Okay, so if you go to variable view, you can relabel this type to be the correct type. So if you go, so what I did was click on variable view down here, that tab, and then I'm going to click on the three. So I have, when you go over values, you can click on these three buttons, the three dots, and I'm going to put in one. I believe one was, where's my Excel sheet? So put in one is grocery. Oops. Sorry about that. I lost my window. I think. Okay. One is grocery. Two was restaurant. Three, what was that? Retail, and then I have workplace. Retail, oops. And then four, so I have four different groups. So again, what I'm interested in is my null hypothesis is that between these four different groups, there's going to be no differences in the number of coronavirus, positive coronavirus staff. My alternative hypothesis is that one of these places will have a higher number of coronavirus positive staff. Okay, so then I press OK. I go back to my data. And then I am going to go to Analyze, Compare Means, and then One-Way ANOVA. So the dependent, right, so our outcome measure is total number of confirmed staff, right? So those are the number of positive coronavirus staff. And then our factor is what I just put 1, 2, 3, 4. So it's grocery versus restaurant versus retail versus workplace. So our factor is pretty much our group assignment, our different groups. And then I want to look at post hoc, and 2K is a very common post hoc test. So what the post hoc tests are doing, so remember, if we find that we reject our null hypothesis, all we know is that one of the means is different. We have no idea if mean 1 is different from mean 2, 2 is different from 3, or 3 is different from 4. We just know that one of those means are different and causing a significant effect. So with a post hoc, you can see exactly which group is significantly different. So 2K is just a common post hoc test that is used, and so is Bonferroni. So I'm just going to choose 2K for now, and then press options. And I like seeing the descriptives, right? So we like seeing the mean, standard deviation. It might be interesting to see the means plot too. And this is the confidence interval, so I'm just going to keep it 95%. And that's all I want to do. So now I'm going to press OK. And these are the results now. So at the top, it looks like my descriptives are here, right? So these numbers will go into our write-up, right? Our mean, and then, okay, so notice how there's a lot of workplace. So workplace, so for any group that I was looking at, so you know how I manually went through and just assigned each of those outbreaks into a group. And the thing is that there's a lot of workplace because I'm not sure, that was sort of my catch-all group. So anywhere that I wasn't sure if it didn't fit into grocery, restaurant, or retail, I put into workplace. Okay, how do I go back to that window I was just in? Okay, that's weird. Okay, so, oops. I think sorry about this. I'm having a lot of technical difficulties right now. So that's why, so these groups are actually very not equalized. And then you can see that the means seem to be, seem to have some variation. If you look at the standard deviation, standard error, there's some differences. So, oops. So then, here's where we're interested, right? So this is our F statistic. This is where it calculates our F statistic. It tells us our sum of squares. It tells us the degrees of freedom, and then our mean square, and then finally our F value and the significance level. So the F value, so for your write-up, put in that the F value is 0.861 or whatever, it should be the same, hopefully. And then also the significance level. So it looks like we failed to reject the null hypothesis because there aren't significant differences between the groups, even though it seems like, okay, I need to stop. I'm trying to scroll with my mouse, but I think I have to click. So it seems like, this in the workplace, there's a lot more, 11.10. But if you see the variation or the standard deviation, you can tell that it's very widespread. So that's why it didn't come out as significant. So what I can conclude from this is that there are no differences between there aren't differences between total number of confirmed staff in these 4 different groups. So there's no difference between grocery, restaurant, retail, or workplace, and the number of confirmed coronavirus staff. So pretty much, if you want to apply that, anywhere you go is equally as likely for you to potentially have the risk of being exposed to someone who's positive with coronavirus. And then, so because there's no significance, we can't look at the post hoc. There's no point in looking at the post hoc tests, but you can see that they're all non-significant. So what it's doing is comparing grocery to restaurant, grocery to retail, grocery to workplace. So if we had a significant F test here, then we would look more closely at these post hoc tests and then say, okay, grocery, if this was less than 0.05, then we say grocery is significantly different from restaurant, and that there's a higher number, right, of outbreaks at grocery compared to restaurant, that if this was significant, but this is not. None of these are significant. But you can see how you can follow up and do a post hoc test on these each of these groups. And then finally, the means plot just shows that this was the mean for grocery, mean for restaurant, mean for retail, and mean for workplace. So that's why I labeled the numbers, right? Otherwise, we wouldn't know. We would just see 1, 2, 3, 4. But by labeling it, you can see which ones are significant, what numbers correspond to which. Okay. Okay, that was, so now I want to show you how to save your output. I think if I just I think I have to do, oh no, sorry, I keep forgetting. I have to export. So export, so this is where I believe it took me a long time to figure out. I think I need to put in temporary folder file, and I'm gonna call it, but I wanna save it as a, so I'm gonna change this to PDF, because that's easier to work with. And then I'm gonna save in this temporary folder files and call it lab4. So I just click here and then click, I think I need to save in home folder. I don't know why it's, oh, okay. So maybe I can't save it. I'm gonna save in temporary files. Uh-oh, I think I messed, okay, no, there it goes. Okay. Uh, then I'm gonna press, okay. It should export everything. So then I'm going to go into my folder and I am going to download. Right? Okay. And it looks like everything's here. So I'll check all. Once you download, make sure everything is in there. And then, okay, so let's go back to the slides. So, and these were just going through the instructions, but when I used to teach in person, we had access to SPSS in the lab. So these are with the old way that I used to use. So we did it the same exact way. We compared means, we put in the factor. We talked about a significant F value, but what does that mean, right? So then we had to do post hoc tests, and I talked about that. This is 2K's HSD, 2K's post hoc test. This is how you calculate it, which I don't expect you all to memorize. So yeah, I'm showing all the steps. Okay, and this is the write-up. So I always get questions about this, but what I want is for you to write out something similar to this, or in the text, you can write out the means and standard deviations. And then you can also write out what's the most important part is the F value and the significance. And then also say, what the result was. So you have to say, so because our F value was non-significant, you would just say because the F value was non-significant, there are no differences between groups, and therefore we don't find that staff in one particular setting are more likely to have COVID-19. Okay, so all of that is due December 10th, I believe.